Sweet. Now it's going. I forgot to do it yesterday. Yeah. So we do definitely see X, Y, and Z, right? So I'm going to say points X, Y, and Z. That's it. It's very simple. And this is not terribly exciting stuff. I do have to really be honest with you guys. It's not the most exciting topic, but we do have to do it. We have to make sure you guys are comfortable with terminology. So points X, Y, and Z. Yep, that's it. And we usually label capital letters. So you use capital letters. By the way, I don't have the best handwriting, so if you have a hard time reading, please let me know. I'll definitely try to clarify. I'll try to use a font, or sorry, a color that's easy to read. So use capital letters typically when we state points, right? So that's all. Okay. Russell, right? Yeah. Well, can you read the next part? What says line?
That of all points.
Okay. And what about the bullet points right below? Correct. So if we look at the next diagram, right? Now, so first of all, you see a lowercase k, and then you see uppercase for these other three letters. How many points are displayed on this line right now? Just three, right? I just see 3 points. However, are there more than 3 points on the line? How many are there? There's so many. I don't know. There's a gazillion, right? I have no idea. So, yeah, it's infinite, right? And also goes forever in both directions. It goes forever past N, forever past D. So it definitely goes forever. And also, there's infinite. There's so many, right? Now, how do we label it? How can I call this diagram? What should I? Let's use maybe pink. So how can I label it? You can label it a few ways. You can call it line K. So sometimes use a lowercase letter to give a label to it. You call it line K if you want. You could also use the points on the line to label it. So I could call it DE. However, you don't just write DE. There's a symbol you have to put on top of it. Do you know what symbol you put? Yeah, a little line symbol. Yeah, thank you, Kelsey. Yeah, perfect. But could I have label it with other points? Sure. Give me some other examples. Yep. DN, EN. Can I reverse the letters? Yep, I could totally reverse the letters, right? I could say ED, ND, or NE. There's so many ways.
Be like 2 letters though?
Yes. Oh, great question. Yes. Has to be 2 letters. 100%. Must be 2 letters. Or sorry, must be 2 points. Let me rephrase that. Because there's a lowercase letter that is strictly for labeling the line. Like I use lowercase k. I could use like L, M, N, O, P, whatever, right? A, B, C, D. Pick any lowercase letter. However, if you're picking points, yes, you must have 2 points, 100%. So ND or NE. And again, I know this seems very basic, but you'd be surprised. Some people sometimes mix this up. I don't want any of this to be mixed up. Like about a month from now, like this has got to be toy. Okay, pun intended. It's got to be straight. You get it? Line straight. Okay, I know. Dumb dad joke. All right, I'll throw them from time to time. But Kelsey likes them anyway. So, but yeah, we wanted to make sure we're cool with the labels. We don't want this to be an issue about a month from now because we got other stuff we have to do. Okay, so that's a line. All right, I don't want to spend too long of that. Braden, right?
Yeah.
Yeah. Do you want to read the next one about planes?
Yeah.
Right.
A flat surface made of infinite ends.
Correct. So it's like a rectangle or parallelogram, some shape, right? So it's got to be 2-dimensional. So now we could use letters to label it. Like for example, I can call this like plane X or plane Y. There are 2 different planes here. And by the way, there are infinite dots. Look at all these dots here, right? There's all these dots on it. You could also label it like this too. What if I gave labels each corner? So each corner could have a point, right? What if I label the corners like that? Then how would I name this plane? Just state the 4 points, that's all. But here's the thing, you only need, and this is very important because we're going to talk about this later today. You only need 3 points to define a plane. So Patrick, right?
Yes.
Yeah, I like the observation made about the line. Do we need 2 points? Yes, we do. For a plane, you need at least 3 points. So I didn't have to say ABCD. I said ABC, that would have been enough. Because the assumption, this is the other thing too, it's kind of weird. This plane looks like it has boundaries. They don't have boundaries. The line doesn't have boundaries. The plane doesn't have boundaries either. This actually does move on forever. Like this can extend and expand or enlarge as much as I want. Like this whole board could be a plane, and then you could go beyond the ceiling and the floor and everywhere, right? Yeah, good, Patrick.
For a line, is it like 2 or more points you need, or is it has to be
At least 2 points, but you can do more.
You can do like 3 points.
Sure. But we use 2 points to label it though. Yeah, it's kind of weird to label it 3 points. But yeah, you need at least 3 points to define it. Another place where you've seen a plane before. Hopefully you guys have seen this back in Algebra 1. So what am I drawing right now? What is this called? Coordinate plane. And we call it coordinate plane because it is a plane. So we call this a coordinate plane. It could also be called an XY plane. And we're going to be working with that a lot in this year, right? Coordinate planes or an XY plane. So when I say an XY plane, I'm talking about a plane with 2 lines that form a right angle, of course. And it's 2-dimensional. And we put XY coordinates on it. So we call it coordinate plane also. Nick, right? Do you have a question?
Yeah, would those shapes go on the coordinate plane?
You could if you want. We don't have to, we could. Yeah, and then of course you have plane Y here. So that's a plane. Flat surface, 2-dimensional. All right, so just to recap, a point is just a dot. A line's a bunch of dots. That's 1-dimensional. A plane is also a bunch of dots, but it's 2-dimensional. So now naturally we're going to progress to 3-dimensional. So again, trying to remember names. Let's see here. Anya, right? Yeah, great. Yep. 3-dimensional. So for example, you could say a cube. And when I draw cubes, they're a little tricky to draw. I'm not the best artist, but I think I do a cube pretty well. I'm trying to be humble, sorry. Usually I draw 2 squares that are kind of off-centered. So like, it's taking up space, right? It's kind of like if you have a bin in your house and you put stuff in your bin, that's a cube, right? That takes up space. It's actually, we use volume to measure that, right? Because you have 3 dimensions: length, width, and height, right? So it has 3 dimensions. This classroom, right? Because we have the ceiling, the floor, we have the walls, right? We have all the space in here, right? So this classroom can be considered space. A box. I have this like plastic box down here, right? Like whatever, right? So all these things are considered space. We actually don't really play with this until the spring, but for now we just want to define it. Okay. Now this one seems kind of weird, the way it's spelled. I don't like the spelling of it, but I'll have Nick, do you want to read the next one about collinear?
Collinear points on the same line,
And the next one also.
and non-collinear
Yep.
points not on the same line.
There we go. Now we hear the word co. For example, I know some guys play sports, right? Like, you guys have a football game today? Yeah, so you have co-captains, right? What does it mean to have a co-captain? 2 people, yeah. Or what if you are on an airplane, you have 2 pilots? You call them the co-pilots, right? So co means the same. Linear, of course, means line. On the same line, right? Co means same. So are X, Y, and Z on the same line? Yes, right? So we'd say X, Y, and Z are collinear. X, Y, and Z are, and it's just such a weird spelling with COL. It is what it is. I do code dash linear, but whatever. It's like collinear. Okay, non-collinear when they're not in the same line. So what if I drew a random point kind of floating above? So give me 3 points that are not collinear on what I just drew. Actually, Kelsey, you want to, with 3 points would not be collinear? Perfect. AX, Y. Great. AX and Y. Correct. Are not collinear or non-collinear. Now, by the way, you need 2 points to define a line. So, a line, any 2 points. Well, let me phrase this correctly. A line passes through any 2 points. Just like how we said a plane passes through any 3 points, a line passes through any 2 points. But to be non-collinear, there has to be a minimum of 3 points to be non-collinear. Like you can't say, can you say X and Y are non-collinear? No. Like any 2 points, you can make a line. XA are linear, right? They could be or collinear. But to say something's not collinear, you have to have at least 3 points to make that statement. So like XYZ, of course, happen to be collinear, but AXY is not. But any 2 points, you can make a line. Does that make sense? Okay, cool. Now you want to read the next part about coplanar? Yeah.
Coplanar, points on the same plane, non-coplanar, points not on the same.
Perfect. Good. So here I got 2 planes and they're intersecting, right? Now the intersection, we'll talk about that right down below, is a line. This line here is going to be the crease here. If you took, like, say, I'm not going to do this, but if I took these 2 pieces of paper and like ripped them in half and like kind of partially ripped them in half and kind of like try to wedge them through, that crease would be the intersection between the planes. But we'll talk about intersection in a moment. Let's talk about what's coplanar. Let's say I focus on the horizontal plane. Give me 3 points are on the horizontal plane. Ali, you want to tell me what 3? There we go. Perfect. Good. PUG. PUG are coplanar. Awesome. What if I take a look at the vertical plane? What are some points that are on the vertical plane? LUSK. You'd agree? Yep. LUSK. Yep. LUSK are coplanar. Good. However, non-coplanar, they're now you have to be careful here. I said this earlier. Any 3 points define a plane. Just like any 2 points define a line. Any 3 points define a plane. So you have to be careful. Some of you guys might say LUP, but you can make a plane with LUP, right? I can make a triangle, and that'd be cool. So you have to say for non-coplanar, you have to give me at least 4 points. So a minimum of 4 points would ensure that you're non-coplanar. So looking at the diagram, give me 4 points that would not be coplanar. What do you guys think? Are all 4 of these on the same plane? Nope. PUG are, but is L part of PUG? Nope. L is part of U. L could be part of G or P, or LUP could be the same, but all 4, no way. No way. So LUPG are non-coplanar. And we're going to be dealing with a lot of, now just so you know how this is going to be assessed, we do this as true-false questions. So I'll give you a diagram. I'll give you some statements. It'll be true-false questions. You're going to practice that later in this stuff. That's something that we assess. We assess this as a true-false type situation. Okay, now do you want to read the part at the bottom that says intersection? Yeah, the bottom. Yeah. No worries. You're busy writing. That's good.
Where the 2 positions.
Right. Intersection is a big deal. I'm sure you guys have played around with Desmos and graph lines and stuff like that. So, for example, if you have 2 lines, they can intersect. When they intersect, the intersect, how does the intersection look? What do we call that? What does that represent, that intersection? Sorry, I'm not asking the question correctly. What shape do I see when they intersect? Or what geometric term do I use? They intersect at a point. Good. So it's intersect at a point, right? So we call it a point of intersection. Because the point where they meet, right? Okay, I can't spell. Now planes, I don't want to try drawing because it's kind of hard to draw. But for two planes, where they meet, two planes, they have a line of intersection. That's what they have in common. So that line right there, I can't label it because I don't have enough points to label it, but yeah, that would be the intersection. Okay, we're good so far. All right, we're gonna keep moving. Again, just bear with me. This is not the most exciting stuff. I try to do less lecture and more practice, but today we kind of need to do this, and we have 75-minute periods, so it feels like a good time to do it. All right, let's move on to the next table. Actually, let me read. Let me write this first, and then Patrick will have you read it. But let me write it first. And I'm going to type because some of my handwriting's not the best. Okay, Patrick, can you read that statement, please?
Y between points X and Z, that means that Y line from a line X Z between this implies points X, Y, and Z are coded.
So let's look at the diagram right below, right? I have X, Y, Z. Y is clearly between X and Z. So what that means that if it's between, it's going to lie somewhere between X and Z. And the implication is that they're going to be collinear. That's the implication. Thank you for that. So now let's talk about segments and rays. That's a new thing we need to talk about. So a segment is essentially a portion. So this is what how segments defined. It's a portion of a line with two endpoints. Still, there are infinite points. I think I'm going to use a text box to write the next one. And I'm going to try using my iPad eventually because the stylus there is much better. I can use my mouse. So let's kind of pause a little bit here. So that's clearly a line, right? You see the double arrows. But XZ is a segment. So it's a portion of it. So I'm going to take, it's like if I cut this out, right? But here's the thing, it doesn't go on forever. There's an end to it. There's a beginning, or there's a left end and right end. It's probably better way of saying. Because what's beginning, start, end, starting or ending. Kind of weird. There's a left and a right. X is the left, Z is the right. So the portion line with two endpoints. Still, there are infinite points, right? Like how many points are between X and Z? I don't know. There's so many. I don't know. Right? It's infinite. So that's what a segment is. You're taking a segment of something, just a portion of it, right? That's all you're doing. So if I highlight it, it would look like this. There we go. That's my portion. We're good, right? Now let's take a look at over here. Now I'm going to call this array. Now, array, let me type this up. Is also a portion of a line with one endpoint and goes forever in the other direction. Still, there is, terrible grammar, there is an infinite set of points. There we go. So you start here. You do that. You start at X and go towards Z. That's still array. It's still a portion of line, but you chop off this little left part, just throw it away. Chop off the left arrow, keep everything else. There's an endpoint, just one, not two, just one. And it goes further in the other direction. That like a sun ray or light ray, like that. Or laser rays or beam rays, call them whatever you want. Okay, so we want to make sure we're clear on that. What is a segment? What is array? A line goes forever. Segment is a portion with two endpoints. Array is also a portion with one endpoint. So line, segments, rays. Make sense? We're good? All right. Now opposite rays, let's have Anthony, right?
Yeah.
Yeah. So can you read the part about opposite rays? Mhm. Yeah, keep going. Yeah, sure. Good, excellent. Thanks so much. Yeah, so a common endpoint that form a straight line. So you could say this. I could say yx and yz. Okay. So yeah, we do uppercase letters, same uppercase letter. So like for example, if I erase this one right now, let's use different colors. So I'll call this yx and I'll do this in red. I'll call that yz. So notice both those rays start at the same place, but they clearly go in opposite directions, right? It's pretty obvious. One's goes toward X, one's going towards Z. So those are the opposite rays. Common endpoint, but opposite direction. And of course, together they form a straight line. So you don't want to do this. That would not be those would not be opposite rays. In fact, actually, what did I make here? What do you guys know what we call that? Go ahead, Patrick.
Right angle.
Close. Well, just an angle in general. It's not. I don't. What would make it right? What would have to? Well,
It was like
Square thing.
it'd have to be like 90 degrees
Yeah.
exactly. But it's an angle, sure. Yeah. And we're gonna talk about that in a moment. We'll actually talk about that on the next page. All right, let's keep moving. Any questions so far? That's a big information dump today. All right, let's keep moving. Emily, right? Yeah. Do you want to read the part about distance, please?
Distance, every point can be compared with a number on the number line. How do we find the length of a segment on a number line? Please phrase a rule that.
Okay, here's how I'm going to phrase it. It's simply the positive difference between 2 points. That's it. Just keep it very, very flat. Positive difference between 2 points. So, for example, say look at J and L. What's the positive difference between -3 and 2? How far apart are they? If you count it.
5.
5, that's it. Yep, it's 5. Or let's look at KM. How far are K and M away from each other? 4. There you go. It's that simple. Now it gets a little funny at the next one with PQ. And I didn't put P and Q on the diagram. Let me make a new line. Let's say this is X. This is Y. I have no idea what numbers X and Y are. No clue. So P goes with X, Q goes with Y. So I want to find a distance of that. Here's what I'd write. I can write like this. Or I can write like this. Okay. So. Does anyone know what the symbol is? What's the symbol called? Absolute value. You guys remember what absolute value means? What does it mean? Brian, any idea? Yeah, good, yeah, good, yeah.
It's like the total value, but not, negative, or just like.
So let's pause exactly. So for example, what's the absolute value of 5? It's absolute value of -5. It's always a positive number, right? It's technically we could say it's a distance from 0 on a number line. The positive difference, right? So why am I putting absolute value here? Because I don't know if X and Y are negative. I have no clue. And why did I have to put X? Did I know X is to the left of Y? No. Was there any indication X had to be to the left of Y? No. I just did that randomly. I could have reversed it. But in order to guarantee a positive outcome, we need to put absolute value. By the way, these are both the same thing. You can write either one. Either one's legitimate. You don't have to write both. Either one's fine. But you need absolute value. So let me type this up. Absolute value guarantees a positive result or positive output. That's probably a better way of saying it. Guarantees it. Now, this is a notation thing that is kind of funny. And I'll be honest, I actually didn't know this till yesterday. So I'm learning new stuff too. If you see this right here, that means line segment.
Like the line above the.
Correct. So what does that mean? That's simply just going to mean segment JL. So it basically represents a geometric object. So when you see that, when I say, little bar JL, I'm referring to a geometric object. So when you see that again, think geometric object. Now, if you don't see it, if it's blank, that's going to represent the distance between J and L. If you don't see it, notice I didn't put that up above when I said JL, CAM, and PQ. That represents the distance between J and L. So that's going to be a number. Geometric object, a number. Okay. So questions so far? You're hanging in there? All right. We're going to be done with this fairly soon. Adam, do you want to read the part about segment addition postulate?
These three things you then.
All right, so here's what we're gonna say. Let's draw a line. Let's put A, C, and B. I think it's pretty obvious, but we need to talk about it. If I add AB to BC, what would that equal? There we go. That's it. That's all it ever is. Those two segments, AB and BC, do they make up AC? Yeah. Two parts make a whole. Yep. That's all it ever is. As an abbreviation, we write as SAP. Also, the term postulate. We're going to be talking about this a lot in a few months. On the poster board, you see like parallelogram proof and some other. You see these two columns and these diagrams and all these words and stuff like that. It's not fun, but we're going to do it. Postulate is considered a fact. Just have to accept it. So there's nothing to prove. You just accept it. It's kind of like, for example, it's a fact that Mr. Dioli is our director of schools. This school was established in 1898. You're not going to dispute those things. Those are true. Am I going to dispute that AB plus BC equals AC when I look at this diagram? No, I can't dispute that. It's very obvious, right? So that's a postulate. Just so you know that what that term means, postulate. Other things we prove, those called theorems or theories. We prove theories. You have a theory about something like, I think we're gonna have an earthquake next week. Okay, I gotta prove it now. I gotta show like all this evidence, right? That's a theory. But postures are things you consider as fact, as a matter of fact. Definition of a midpoint of a segment. Marco, do you want to read that? Actually, do you want to read the next two highlight parts? So if we look at these two diagrams here, right? Is X cutting AB in half? It is, right? Because what are you creating? AX and XB. And what are the values of AX and XB? They're both 4, right? So in this case, X is halfway between A and B. X is halfway between A and B. That's the midpoint. That's all it ever is. Bisector is usually a line, segment, or ray that cuts another line segment in half. So if I drew this, that's called a bisector. Bi means 2, sector means section. You're creating 2 sections in half, 2 equal sections. So that's called a bisector. So we'll talk about it often, but bisector is cut. That's all, just cut. Midpoint, point in the middle, right? Middle point, makes sense. Okay, questions? They're going a little faster. Okay, now told you we're going to talk about angles. Juliet, can you read everything in that box there? Mhm. Angle Q. Okay, excellent. Thank you. So yeah, let's define an angle first. So an angle is simply going to be 2 rays with a common endpoint. By the way, there could be opposite rays, and we would create something called a straight angle. But for the most part, they're usually not going to be straight. So the sides, my sides here would be OD and OG. Let me draw a little better. OG. The vertex, of course, is point O. So angles must always have 2 rays that have a common endpoint. The common endpoint clearly is O, OD, OG, there's my rays. Now labeling, you could label it with 1 point. I call this angle O if I want. Or I call angle 1. Do that too. Or you can label 3. DOG. Or GOD. Now here's the thing. Never ever use 2 points. Like, can I call this angle OD? That'd be weird because it's not clear. If you call angle OD, I'm confused because where's the other ray, right? I can't do it. Can I call it angle OG? No, I can't. Can I call it angle DG? Put the O in the middle because then we're getting lazy, right? So I need 3 points. Or you can do 1 point, but the 1 point you choose has to be the vertex. The vertex is that sharp corner or that common endpoint. But you can't use 2 points. It's just too vague otherwise. But sometimes if you go with 1 point, it's vague still. Like, look at this one here. Nick, yeah, go ahead, yeah. What do you
If it
think?
was like, if the angle was like a right angle for the 3 point, for like the
DOG?
name, would you put a right angle in front of it, or would you keep it?
You could, you mean like this?
Or
That's
I'm
sim-
saying, no, I'm saying like for like where you wrote the name,
Mhm.
when you wrote DOG, would you write instead of like, is that the sign you always use?
Oh, I see.
Yeah.
You mean like this? No, we still do this in general. Yeah. I don't know. Maybe you could like a right angle DOG. I think sometimes we just say it's a right angle straight up. I don't think we necessarily do that. But the symbol, of course, you want to recognize. All right. So, Griffin, do you want to read? Actually, well, I'll have you read in a moment. Let me finish off this last part, and then I'll have you read afterwards. So let's look at the next diagram, right? If I say angle Q, that's vague because I don't know what's angle Q. Is it PQR? Is it RQS? Is it PQS? Is it the two small parts or the big part? I got no clue. I have no idea. So what I probably should say is I got to be clear about it. You could say angle PQR. You could say angle RQS, or you could say angle PQS. Clearly, PQS is the big one, right? PQR is angle 2. RQS is angle 3. And of course, this right here is angle 2 plus angle 3. Right, if I add up angles 2 and 3, adds up to PQS. But, yeah. You say angle Q, you're fully confusing. I don't know what you're talking about. That'd be more clear than that. So if you want the big angle, give me PQS. If you want the little one, give me the little one. So make sure you're mindful about that. Sometimes we have to use 3 points. We have no choice. Okay, then let's do this part here. So acute is less than 90 degrees. Right is 90 degrees. Straight is 180 degrees. Obtuse, greater. So it kind of look like this. I should do my little arrows. So we want to be comfortable with this terminology. I think right angle, you guys know. I think that seemed like you guys were pretty obvious. That's all straight, pretty obvious. Don't get too obtuse mixed up. How I remember it when I was really young. Sounds like cute, small, like you know, I had 3 kids. My youngest one was cute, right? Small. I don't know if that makes sense. So cute, less than 90. Obtuse. Obtuse means stubborn. If you were to look it up, being obtuse means very stubborn. Looks like a stubborn angle. I don't know. That makes sense, but yeah, but that's how we need to make sure we keep all these together. That we don't mix them up. All right. We're okay. You know, all right. Yeah, Patrick. Of course, yeah, go for it. Yeah, no problem. All right, so we're gonna do one more page of notes, and then we're gonna start doing practice problems because I don't want to keep talking. I mean, we still got the 9:40 for me to talk for another 35 minutes, and you got 4 to 2 other classes. We got community life gathering also. Hopefully, it's entertaining. I know it's a lot of sitting and listening, right? But we're gonna be doing stuff in a moment, so just be patient. So Griff, do you want to read the next box? That's in green. Okay, great. So adjacent means next to. Like, you know, obviously Griffin's sitting next to Luke, right? So they're sitting next to each other, right? So that's adjacent, right? So adjacent has to be next to, but more specifically for angles, they have to have 2 things happening. They have to share an endpoint and they have to share a side. So it has to be common endpoint and common side. Very important. Also, one angle can't completely include the other angle. We'll talk about that in a moment, what that means. So I'm going to say yes. That one. I'm going to say yes to that one. I'm going to say no and no. So this one, no common side, right? It's pretty obvious. 5 and 6 don't have a common side. But the first two did, right? 1 and 2 and 3 and 4 did. Here, no common endpoint. Right? 7 and 8, those points are here and here. Those vertices. Or no common vertex. That's probably a better way of saying it. No common vertex. Let me change that to let me change that. And then this one is like this. Angle 10 contains angle 9. See how 10 is this whole thing here, but 9 is just a little part of it. That doesn't count. Even though they do share this side right here, and they do share an endpoint, you can't completely contain it because they're not next to each other. It's completely containing it, so it doesn't count. Questions on that? So 1, 2, 3, 4, yes. 5, 6, 7, 8, 9, 10, no. And the reason for 5, 6, not common side. Reason for 7, 8, not common vertex. Reason for 9, 10, 10 complete. Consumes or contains angle 9. It's not okay. Now, definition of an angle bisector. That's when you cut an angle in half. That's all you're doing. So ray QR cuts angle PQS in half. So what it means that angle 5 equals angle 6. Those are equal. That's what it means to bisect. So if PQS, if the whole thing was like 50 degrees, then each is 2.5 degrees. It doesn't look it. By the way, never ever this class go based off looks. You can't go based off looks. You have to prove. So I'd have to tell you, oh yeah, it bisects it. Okay, this whole thing's 50. Then 5, 6, or 25 each. You never go based off looks. You have to have hardcore evidence. Make sure this is all proper. So, correct. Yeah, my handwriting sucks. I apologize. Angle 5, yes, it would. If QR were the bisector, it would. Okay. All right. The home stretch here. We're gonna do some practice problems after that. Okay. Angle addition postulate. I label this as AAP. Just like segment addition postulate, and it's something we consider as fact. So essentially what you're saying here is that if I call this angle 1, and I call this angle 2, I'm saying that angle 1 plus angle 2 equals the whole thing. Or I would say the measure, we use a little m here, the measure of angle DOF. It's kind of a pain. You have to write the little m thing, but I think you actually need to do that. I should have done that earlier with 5 and 6 for the angle bisector. Angle DOF and angle FOG equals the measure of angle DOG. So for example, what if angle 1 were 30 degrees? What if angle 2 were 40 degrees? What would be the measure of angle DOG then? That's it. It's that simple. It's that easy. And by the way, if it's a actually Luke, because I haven't, do you want to read that the next bullet point? Oh, actually, sorry. Where it says if angle DOG. Yeah, then we could say that the measure So it's a straight angle. So the measure of DOF plus the measure of FOG is equal how many degrees? All right, degrees. So what if this were like 130? Then what would this have to be to make this complete? There we go. Yep, excellent. Okay, good. Everyone got the participants. Awesome. And the notes, this was working great. Okay, I'm going to do this. I'm going to put up 4 statements about this diagram here. I'm not going to add anything to this diagram. This is what you see. I'm going to have 4 statements. You can put this true or false. Then you're going to practice this on the next couple pages. So let me type this up right now. Let's see here. Angle. EVs. Of course, yeah. Angles ABD plus angle EBD plus angle ABD. AB points A. Nice. Okay. All right, let's talk about it. True, false. Angle ABC.
Yes, true.
I want to say false.
I was gonna say this.
Okay. Are you're USC fan?
Huh?
You're a USC, yeah. I'm a Stanford fan, but we don't play each other anymore. So I used to despise USC football. Sorry, I'll stop now. But false, good, okay.
Wait, it's false?
Yeah, because I don't know.
Cause it's like straight, right? So.
I don't-
Need to be right.
There's no indication.
Original.
Yeah, there's no proof. There's no proof. Yeah, there's no proof. Yeah, I just don't know. So you can't go based off looks. I would need to tell you that this is 90 degrees, or I need to do this. So that's false. I just don't know. There's not enough information. But how about the next one? ABD and DBE. Do those add up to ABE? Yep, they do. That's true. That's because of the angle. Oh, geez. Angle addition postulate. All right. Are AB and E collinear? Nope. Are BA and BC opposite rays?
Yeah.
They are. Yep. That's true. Should we be going through this kind of exercise on the next page? So here you have a bunch of statements. You have a diagram. You're gonna have to say true, false for a bunch of these. Then you're gonna be naming things on number 2. Number 3, you're gonna be doing more labels. 4 is more true, false. 5 is a little bit of solving. We'll see how far we get in the next 20-ish minutes. I'll walk around and help you guys out. Maybe you guys want to talk about college football, I could talk. Stanford sucks, by the way. We're terrible at football. But I'm happy that we got, Mr. Donahoe's dad is the AD at Stanford. Yeah, that's pretty neat. Yeah. So they brought a businessman in to, anyway.
The Nike guy, right?
Yeah, and eBay too. Is eBay CEO. Yeah. And I taught both of Mr. Donahoe's siblings many years ago. So nice family. So anyhow, let's go through it. But just stay focused. But of course, we can always talk about random stuff if you ever want to. But let's stay focused. Let's get stuff done. Let's try to get as much as you can done in the next 20 minutes in this packet. Then I'll talk about homework near the end. So we're gonna go and I'll put up the answers every 3 or 4 minutes so you guys see what's going on. Yeah, go ahead. Yeah, I don't know if you should have gone to the big. Yeah, I don't know if you should have gone to the Big Ten. Yeah.
Line L.
Oh, yeah, oh, yes, D, sorry, the intersect at point A, there's a typo, my apologies, part D. Yeah, and the symbols are a little off too, I don't like it, but you know.
With that, this is probably a
I don't know about.
Right, right, that'd be.
Actually, I think it does.
Yeah.
Oh, yeah.
Maybe even,